Today we're going to be talking about getting into game development, and it's one of my biggest passions, and I think every developer should give it a try. So let's get to it. My name is Jack, and I work at the firm Graphics. I mainly do front-end development during the day, and then game development on my free time at night. And you can follow me on at Rugile most everywhere. These are a few of my famous quotes. For those of you who don't know me, this is kind of my life right here. So, how many of you guys have made a game yourselves? Whether it be video game, computer game, board game, anything? Okay, we've got like 10 or 11 people. So, my goal for today is, if you haven't, just try to get you into game development, and if you have, just try to make a better game, because it can always be more juicy and polished. So, game dev is amazing, and fun is the main goal of making a game, and that's something that's so different from all the other work we do. Like, I've never had a client say, like, I like the colors and I like the layout, but can you make our website more fun? You know, like, or make our database more fun? You know. So, having a game have the sole purpose of just being fun is totally different than normal work, and that's really important. So this idea of recreational coding, which I do in the form of game development, is really important, because it's nice to have something where you're not worrying about a paycheck or client deadlines or client budget or client constraints or just straight up bad ideas that they give you. So game development is the outlet I use for that kind of thing. And I'm biased towards games compared to other creative forms, because games kind of combine every other single art form into one. So like, these are 8 or so that I picked out, and there's more than this, but a game could possibly include all of these. Sometimes I include 1 or 2, but it's the ultimate creative expression. So there's tons of ways to build a game. If you're going for a console game, or an app, or a board game, there's a million ways to do it, but I figured my crowd here would be mostly web developers, so I think it's best to just start with something you know to lower the barrier of entry, and web languages are perfect for that. So we're going to be looking at ways to get started making games with HTML, CSS, and JavaScript, so the stuff you already know and love. So when you're getting started with game development, I think it's really important to look to games that are already successful, really simple games from the past, like the classic arcade games or early Nintendo games. You can just learn so much from them, rebuilding and trying to mimic those concepts. And so if you're getting started out with game development, I'd say you pick one, make it working in its most basic form, and then once you're done with that, add on your own twist to make it your own. So it's a really simple example. If you were to take tic-tac-toe, it's super fun, super intense. If you were to take it and add on maybe a third player who has a new shape, and maybe your goal is to make some sort of L pattern instead of a 3 in a row, that could be your own twist for that kind of game. And when you start making your own games, the same thing holds true. I think you should really start really, really simple. Pick one game mechanic, get that working perfectly, and then if it's already fun in that state, with just black and white squares on a screen, then you know you already have something really special, and you should iterate on that. Because no amount of graphics or sound can save like a crappy game, you know? Like, you can't just throw that on after the fact and have it be fun. And one of the challenges with building your own games, though, is you don't have any guidelines or roadmap to tell you whether you're going in the right direction or not. If you're making a clone of an old game, you know whether you did it, but you kind of have to use your own judgment and decide whether it's fun or not. And the final point I want to make why game dev is amazing is it's they're having fun. Is when you get to watch someone play the game that you've built, it's so satisfying. Like, it doesn't matter if they're angry or happy when they're playing it, it's so fun. Actually, it's actually more fun if they're angry when they're playing it. Like, cursing at you for building the level so hard. It's the most fun thing. And on top of that, watching people play your game, you get to get the most raw feedback about your game, because when you're playing your game, you get way too close to it, like almost intimately close with your game, and you start to make it harder than it should be because you're getting really good at it as you're developing it. So it's nice to have a fresh set of eyes and seeing them interact with something fresh. So today we're going to build a really simple game, and there's going to be a lot of code. Deal with it, and or enjoy it. And it's going to be one of those things where it's not important to read every single line, but as long as you grasp the concept that we're trying to do with that piece of code, that's the most important thing. And you can come back to these slides if you want to actually dig into it. So we're going to be building Pong. It's like the classic video game in my mind. It's 44 years old this year, I think. And yeah, like I said before, we're going to be using HTML, CSS, and JavaScript. And it'll end up being about 300 lines of code, which is a lot for a talk, but it's not that much for a game. So even a simple game like Pong, you can cover so many fundamentals of game development just packed into that tiny game. Like, we'll be looking at rendering graphics, which are the paddles, the scores, the ball itself. We'll be taking user input from the keyboard. That'll just be the up and down arrows to control your paddle. We'll look at the core concept for every game, which is an animation and logic loop. And that's a piece of code that runs, we're going to be aiming for 60 times a second. We'll be keeping track of the state. So that'll be what the score is for each paddle, where the ball is, where the paddles are. We'll get into some really basic 2D collision detection, which is kind of physics, but it's really not. It's like the most basic physics you could apply to a game. And same thing with artificial intelligence. It's not very smart what the enemy is going to be doing. So first thing to set up is the HTML itself. This is the paddles, the scores, the net, and the ball. And Pong is really great for something that's HTML based because nothing ever gets added or removed from this set. This is just going to stay here the whole time, and that's it. And when you're working with HTML, CSS, and the DOM for rendering, it's nice to just pull everything out of the flow of the document, set it to position absolute, let it live in the top left corner, and then we can use transforms later on to position those pieces. So we've got our Pong wrapper, and that's just going to have a rectangle with a gray border. Very exciting. The paddles themselves, they just have some basic dimensions set, and then a different color for each one. We're going to need the green player, and then the enemy will be the blue color. So we're not applying the position yet, but we'll get there. For the score, we're just going to set up some basic font styles and match the colors to the paddles. And we can actually position these where they're going to be on the screen in their final form because they're not dynamic. They won't be moving. We can just set this here and forget it. Very nice. And then finally, the net and the ball. The net is just going to be a gray line down the middle, and the ball will be a white square. So this is the main structure we're going to use for our game. We've got an initialization function, an update function for the actual game logic, and then a render function, which is basically applying the CSS styles to the elements themselves, like injecting CSS into them in line. And then finally, the loop is something that will run 60 times a second and run the update and render function. Some lovely global variables here. We're going to just set up some basic pixel values for the dimensions and the speed for each component. So the level, which is the game, the paddles, their speed is set to 16, and that's just kind of a number I found that works well. And that's 16 pixels per frame for moving up or down. The ball has 2 speeds applied to it. The start speed is to always contain where it begins, but as the players score, we're going to increase that speed to make it more difficult and more fun. So we're going to track that in 2 variables, and we're going to play to 5, the score max. It's a lot of code, I know, but bear with me. So we need some objects to keep track of all of our entities in the game. So with the player, the paddle is going to have a reference to its DOM element, an X and Y coordinate, which the origin is in the top left corner. So going to the right, X gets greater, going down, Y gets greater. Apply the dimensions and the speed we set before, and then we're going to use move up and move down Boolean properties to determine what direction it should be going at any given point. Same thing for the enemy. We're just putting it on the right side of the screen and referencing a different DOM element. Ball is super similar too. It's just a square, and we actually have a Vx and a Vy property applied to the ball, which is velocity x and velocity y, because we're going to be moving in all different directions with the ball, so we need to keep track of what direction it's going. And the score objects, these are just references to the elements and storing the value for that particular paddle. So here's the render function I was talking about, where we inject CSS into the element itself. And to position them left and right, we're going to use transforms instead of left and top values, because that can be accelerated by the GPU and just runs way faster. You get sub-pixel accuracy in Chrome, at least. And finally, down at the bottom, we're just going to change the HTML for the score elements to whatever they are at that point. So this is our kind of static starting point for the game, with nothing moving. So now we get into the game logic, and we're just going to take this piece by piece and wrap it up in a single function and just keep on applying that. So first thing is to get the ball moving, and to get the ball moving, we just apply the current velocity for the ball to its x and y coordinate. And keep in mind that at any point its velocity can be negative, so we have all directions covered here. Add it to our update function, and then to get actual animation going, we need to set up our loop first. Then we can kind of forget about this. We're using a request animation frame instead of set timeout or set interval. It syncs up with the browser, with the browser's refresh, and causes you to have no dropped frames and no extra frames. Run that loop once, just kick it off in the initialize function. It's kind of working, right? There we go. All right, so let's handle that problem of it flying off the screen. So with the contain ball function, we're just going to see whether it's colliding with the top, the bottom, the left, or the right of the screen, or the level itself. And once that happens, we just reverse the velocity for that axis. Add it to our update function. We're going to be doing this a lot. So there we go. Now moving the player, we're going to be checking to see whether those move up or move down properties are set to true. And nothing will happen until we apply this to the keyboard itself. Well, I'm using controller, but we're just going to program it for the keyboard. And so if we're moving up, we move on a negative value for the speed. And if we're moving down, go positive. Add it to the update function. And so yeah, our event listeners are just going to be looking at key down and key up events. So this is the up arrow and the down arrow. They're assigned to 38 and 40 for their key codes. And we're just going to run this once on initialize. So now I can move my paddle up and down. So for the enemy paddle, we have no one controlling it, so we need to introduce some sort of artificial intelligence, and we're not going to be making Skynet or anything like that. It's like it's not even going to be close. But what we can do is have the paddle look to see whether it's above or below the ball itself, and that can kind of guide its direction. But if we were to do that, the enemy paddle would just be completely perfect and hit it every time, since our vertical speed matches the speed of the ball. So to fix that, we're going to apply some random blindness to the enemy. So with that math.random function, that's going to give us a value between 0 and 1. And if it's below 0.2, then the enemy can react and look to see where the ball is. Otherwise, it's completely blind. So this just introduces some random error to the paddle. You can kind of visualize this, what's going on here. If we run the math.random function 500 times and make them blue for the ones that fall below 0.2, you can see that roughly equals about 20% every time. Just if we run this again. The longer you run it, the closer you'll get to settling at 20%. That's pretty close. So we go ahead and move that into our update function. And now it's kind of working, but it's kind of flying outside the edges of the screen. And in fact, I can do that too. See ya. So let's take care of that. We're just taking this one step at a time. So I'm going to be using the math.max and math.min functions to kind of clamp a range for the paddles vertically. And when you're clamping a range with these functions, I like to think of it as the opposite. So if we want to set a minimum point or a minimum value for where the paddle can go, then we use math.max. And if we want to set a maximum, we use math.min. Add it to the update. There we go. Now we're kind of locked in this world. We can't escape it. It's kind of sad. So the 2D collision is probably the most complicated part of this talk. It's not too bad though. We're going to be using AABB collision, which is axis aligned bounding box. So essentially that's a comparison of two rectangles that aren't rotated. They're completely level on their respective axes for X and Y. And for me, what made the most sense for this kind of collision detection is just determining first whether they're not colliding and then taking the opposite value. And there's 4 conditions that we can check to see whether two rectangles are colliding. So the second rectangle is the white, or the second square is the one we're going to be comparing against. And then we have 4 possible situations that we could be in. So the first situation is that the bottom of the green box is above the top. The second one being that the left side of the blue is on the right of the white. This is really hard to say. And then the same is true for the pink and the orange. So if any of these conditions are true, we know that two rectangles aren't colliding, and then we can check for the opposite of that. So we run this to compare the ball and the player's paddle. And if that's true, we go ahead and set the ball to be flush with the edge of the paddle so that no more collisions occur. And then we reverse the velocity on the X side of things to get it to go to the other side. And then same thing for the enemy. And we fell asleep. Add it to our update function. All right. So this seems to be working somewhat well. I'll go ahead and miss one. And I'll go ahead and get one. There we go. So the ball is contained in the world right now, but really a score should be going up when we hit the left and right edges. So we're going to modify our contain ball function to increase the enemy value and the player value, depending on which side it hits. So let's test this. I'm just going to let him. There we go. So now we can see the score went to 1 for the enemy. And the enemy's being stubborn, so I'm not going to try to score right now. Now when the score does go up, that's the point where we want to reset the ball to the center and start a new round. So when it hits there, we're going to increase the score. We're going to center the ball in the middle of the screen. Set its velocities to 0, so it kind of sits there for a second to give you time to prepare. And then just using a simple set timeout to give it a second before it starts moving again. So we go ahead and add that to our contain ball function. And we increase the speed here while we're at it to make it a little more exciting. You can see we have about a second to respond as it goes. So the last thing we need to do for our game is just check to see if someone has won. And we're just doing some basic console logs to show if someone has won. So we won't see these right now, but yeah, we're just comparing the player's score and the enemy's score to the score max that we had set at the beginning. So that's 5. Go ahead and add that to our update function. I think this is the last update function modification. And then once the player does hit that point, we're going to reset the game, set the ball back to its original speed, set the scores to 0, and then reset the ball, and just do it all over again. So there you have it. This is our game, and you can probably sell it for lots of money. So this is awesome. Like, it's working, and that's huge, but it's really not exciting, but it's working, and it's not crashing. So that's enough for me, but for now, but we can make it better. So from here on out, I'm not going to be showing any more code for the slides. I just want to get into some concepts that you can do to bring your games to life more. And if you want to see the code for these, just let me know, and I can dig up the spaghetti for you. So there's tons of ways to enhance your game, but we're just going to be looking at 3 of them. First, just giving it a name, because we're not barbarians, and we should give it a name. For user interface, we're going to add on a start screen and an end screen. The start screen will have controls, just telling people what they need to press. Gameplay and mechanic changes, those have the biggest impact on your game, because it actually has an effect on the way the game plays. It's not just an aesthetic type of thing. And then the visual and aural changes, they are just aesthetic, and they're not changing the game, but they can really change the way the player feels when they're playing it. So even though they are aesthetic, they are just as important as any of the other changes we make. So first we're going to give it a name, add on the screens I talked about at the very beginning just to prep the player. And then I think it's important when you have a UI element that needs to be referenced at any point to have it be kind of have a way to glance at it from your peripheral vision and tell what's going on. So more than just showing a digit for the score, we're going to show physical bars so that at any moment you can kind of just quickly glance over there and see who has more bars. The name is kind of for this conference. So there we go. I'm just letting him win. So you can see now, like we have a brighter blue color over there from the bars. You can just kind of get a quick glance of who's winning. This one's a gameplay change with acceleration and friction for the paddles themselves. Right now they're moving really choppy. Like right when I click down, it moves down at its maximum speed. So with acceleration and friction, we can speed up and slow down the paddle. So this one's subtle, but you can see it keeps some of its momentum as you're moving it. Feels good. The ball is kind of like this right now. So instead of it having just all of a sudden appear in the middle of the screen, I think it's nice to fade it in and have it slide up just because it looks good. And we're also going to be rotating the ball based on how fast it's going in the X direction. So it just feels like the ball is having more fun. You know, I'm having more fun playing with it. So if we lose that, it kind of like has a nice entrance animation.
Does your collision still work? You're
It does still work, but I'm not applying any of the rotations. I'm just pretending that the rotations aren't happening. And the ball is moving fast enough that you can't tell. You weren't supposed to see that. So right now, there's nothing reacting in the world except for the change in velocities themselves. So a nice way to show that the game world is affected by the things that are happening is to show some flashes of movement. So with this change, we're going to flash the walls, the paddles, and the scores themselves when something happens. We're going to get a little physical kickback or rotation on the paddle when it gets hit. So the side that gets hit on the level will flash, and we just get a little bit of rotation when we get hit. And if we score, there's just a flash on the screen. It gives you an idea that something major has happened, which is someone scoring. CSS comes with more 3D power than you think, and we can add on some simple 3D rotations that have no effect on the gameplay themselves, but just add some visual interest and depth to the game. So we're going to be rotating the entire level based on the X and Y axes based on where the ball is. So this has nothing to do with gameplay. It just looks cool. And along the same lines, we can create somewhat 3D rectangles by extruding them out from the ball and the paddles, and basically turns them into cuboids. So this gives them a kind of a pseudo 3D effect, and all the lighting on all the sides of the panels is completely inaccurate. Like you have two shadows right now on the right and the left side, but that really doesn't matter. It's just aesthetic. So particles are one of my favorite things to add. There's no purpose for them whatsoever, and they just really look cool. That's basically the motto of my talk, just make stuff that looks cool. So particles are different though. This is where we get into adding and removing elements from the stage or the level. And it can be really non-performant to create an element every frame and put it in the DOM and then remove it when it's dead. So what we're going to do is pre-allocate some objects to be particles, and they're going to be sitting off screen somewhere, just ready to be pulled. And then when we need them, we set their properties, put them where they need to go. Then when they're faded out or dead, we can put them back in the pool for recyclable use. And this is way better for performance. So now, when you create them where the ball is at any given point, it gives it kind of a trail effect. And then when the paddles get hit, you can really feel that they're getting hit now because they actually shed some of their own color. So adding in sound effects is one of the most impactful things that you can change in your game to make it, to get the player to feel feedback and like there's something happening in the game. So it's the only one that adds a new sense to the game, and it's something too where if you play the same sound effect over and over again, it can get really irritating and annoying. So what we're going to do with each sound effect is vary its playback rate just a little bit randomly each time it plays. It just gives it a little bit of variation. I might have to adjust the volume, so look out. So that just it makes it so much more fun to play. So they're kind of intense sounds, but it almost makes them feel like they're big blocks of metal or like meteors flying through the air or something, instead of just little plastic pixel pieces. So screen shake or camera shake is super powerful and really easy to overuse. So whenever anything happens in the game, what screen shake will do is just kind of set a random vibration for shaking to the entire level. And to keep this effect looking nice, you need to have a contrast between the resting state and the chaotic shaking state. Because if you overdo it, then it's just always shaking. If everything is important, then nothing's important. Things are getting more exciting now. And when I unpause it, look at how the screen shakes when I hit the paddle versus when I hit the wall. When I hit the paddle, I apply some sort of magnification on the X side so that the screen is actually reacting to the direction that the ball is going, and it'll hit left or right. So this isn't just a random shaking of the screen, it's actually reacting to what's truly happening. So right now, when the ball hits the paddle, it's been kind of locked into a 90-degree bounce, and that's so boring. Like, there's like nothing fun about it, and there's no real strategy to it. You just need to make sure that your paddle is where the ball is, and that's it. So if we add a variable bounce angle, depending on where it hits the paddle, we can create tons of different variations and kind of guide the ball. And this isn't physically accurate. It's actually way less accurate, but it's more fun, and that's always more important. This is just a quick illustration of what I mean. On the left, it's always going to be that same angle, but on the right, we can kind of choose where we want the ball to go. It's hard, but we can. Whoops. So if I hit dead center, it's going to go straight across the screen. And let's have it hit the edge. A lot more interesting that way. So the next change we're going to make is kind of what I was talking about before, where you make a classic game and you put your own twist on it. I'm going to add kind of a special move to my paddle. That's going to be a spike move. So what's going to happen with this is, if I'm holding down the spike button, it's going to charge up, and then when I release that, it's going to hit the ball and send it off flying super fast. And there is a price to pay for this though. If you're charging, you can't move as fast, so you need to make a decision whether you want it to be faster or more powerful. It's fucking powerful. So when you add this, it makes you too powerful, and it kind of ruins the fun of the game, so we need to make the AI just a little bit smarter. And the way we can do this is every time you hit the ball, just send out kind of a ghost future ball that's moving at a faster speed that the enemy can then react to. So the enemy is basically going to be time traveling and reacting to things that will happen. It's pretty intense. And let me just show you a visualization of what the enemy's reacting to. So right there, actually, hold on. The red ball is basically where the ball is going to be, and it stops on the edge once it scores, so that the enemy is going to just go to where it will be and then just stop there. So this is what our brains are doing. We're trying to predict and see where the ball will go, but we need to give a way for the paddle to do that, or the enemy paddle to do that. One other thing, as we score more and we get closer to beating the game, we're going to send that ball into the future even further. So you can see right there, it's already getting a little bit smarter. So it just continues to get more challenging. And the last thing today I want to add is just something to add to the mood of the game, which can completely change the feel of your game, and has no impact on the gameplay itself. Let's get a full charge going. Oh, God. How embarrassing. Should I just beat him? Yes. You guys are making me nervous. Alright, I got this. With all this stuff I showed you with the basic code and then the enhancements, my main goal is just to get you into reading your first tutorial about making games and just give it a try as a fun hobby to do outside of your main work, because it's so easy to burn out and there's nothing serious about this. It's so fun. Like you can't do any wrong. So thank you guys.